Hello, everybody. Welcome to my presentation. I am part of the IB Worldwide Academy and one of Mr. Anshuman's students in the chemistry department. Today, I'll be presenting the history of the atmosphere. So here's a timeline that shows the formation and the beginnings of life in the Earth. Around 4.6 billion years ago, the Earth formed, and not long after, around 4.5 billion years ago, volcanoes erupted and formed gases. Between 4.4 and 4 billion years ago, the first water appeared on the Earth's surface, and by 3.4 billion years ago, the first simple organisms began to evolve. And around eventually 2.7 billion years ago, the bacteria and algae evolved. This timeline highlights how life developed very gradually after the Earth was formed. Scientists, sorry, yeah, scientists believe that the Earth first formed about 4.6 billion years ago. But at the beginning, it looked nothing like the planet we know today. It started as a molten ball of rock and metal made up of minerals such as iron, nickel, and sulfur. For the first billion years, Earth was an extremely hostile place, very hot, violent, and unstable. Its surface was constantly reshaped by intense geological activity. The crust was covered in volcanoes and erupted and made gases that built up to form the Earth's first atmosphere. Importantly, there was no oxygen yet, which made it very different from the atmosphere we depend on today. Around 4 billion years ago, scientists believe that water first appeared on Earth. There are two main theories that shows this. The first is the icy comet theory. It believes that comets bombarded the Earth in the late heavy bombardment era. When they hit the hot surface of the Earth, the ice melted and filled craters and hollows in the crust with water. The second is the water vapor theory, which believed that water vapor produced by volcanoes condensed in the atmosphere as the Earth cooled and fell as rain, which collected in the crust. Here's a small diagram which shows the icy comets. So, whether Earth's water came from comets, volcanoes, or both, these processes gave rise to the first oceans. Now, around 3.4 billion years ago, the first life started to evolve. The first simple life formed appeared. These were anaerobic microorganisms, which means they didn't need oxygen to survive. Two important groups were methanogens, which produce methane gas, and thermophils, which are archaea that thrived in the extreme heat of volcanic vents. These early microbes lived near hydrothermal vents on the seabed. They gained energy by breaking down chemicals in their environment rather than using oxygen. Life therefore began in some of the most extreme environments on the Earth, places that even today only a few organisms can survive. 2.7 billion years ago, um, the first bacteria and algae had evolved, and they were the first organisms to photosynthesize. Through photosynthesis, they used sunlight, water, and carbon dioxide to make glucose. The byproduct of this process was oxygen. At first, oxygen built up slowly in the oceans and atmosphere. Over time, it removed carbon dioxide from the air and transformed Earth's environment. This gradual increase in oxygen eventually led to one of the most important turning points in history, the Great Oxidation Event. The Great Oxygenation Event, happened around 2.4 billion years ago. At first, the oxygen being produced by early organisms reacted with the iron in the oceans, creating iron oxide. This forms the banded iron layers that we can still see in ancient rocks today. For example, in museums, you can see rocks which have like small layers like this, which are formed due to the oxygen reacting with iron in the oceans. Once most of the iron was used up, oxygen began to build up in the atmosphere. This was the first time free oxygen appeared in the Earth. The consequences were huge, however. Many early organisms, which we saw in the last slide, couldn't survive in oxygen-rich environments, which went extinct. But on the other hand, there are some advantages, such as oxygen allowing more complex life forms to evolve, since it enabled aerobic respiration. This event also affected the climate. Oxygen reacted with methane, a greenhouse gas, which may have triggered the ice ages. So, overall, the Great Oxygenation event was both destructive and life giving, which shaped the path of life on the Earth. Now, here's a before and after of the atmosphere. On the left, we can see the Earth's early atmosphere, where the carbon dioxide is the main sector. And on the right side, you can see the Earth's atmosphere today, where nitrogen is the main sector and there's much more oxygen than before. But why is there more nitrogen? Here we can see the reactions which formed nitrogen and removed methane and ammonia. In the top reaction, we can see methane reacts with oxygen to form carbon dioxide and water. This meant that all the methane that was formed by volcanoes was removed. In the second reaction, we can see ammonia reacts with oxygen to form nitrogen and water. This meant that the ammonia was being removed and lots of nitrogen was being produced, which is why we saw in the last slide that there was lots of nitrogen being produced in today's atmosphere. So thank you for listening to my presentation, and if you have any questions, put them in the comments.